All right, so last time we were talking about abstraction and encapsulation, and we'd gone through this, pretty much almost done with the demonstration here of this isotope class. The encapsulation was that we grouped these 5 pieces of data together into one logical unit. We protected that data by making them all private and making it immutable. And then we grouped the functionality that acted on that data, the decay of this radioactive isotope, in the class itself. And you can see here that it has changed a little bit over here of how we use it, right? We create a sample now, and then we simply say, all right, decay yourself by 1 unit, right? And we have pretty much the same exact outcome over here. That is the same output, but it is way more object-oriented programming, right? Just look at this one simple line, right? This sample decay. Right? Isn't that so much better than what we had before, where we were locating all that complex math? It's not that complex, but we were locating it outside the class. Now it's inside the class, and we have a human-readable term for what the action is. Right? Decay yourself by 1 unit. Now you might remember, since it's only been 2 days, what that unit was. But if you were to come back 6 months from now and look at your isotope class that we just wrote, would you know that that was, well, what was it anyway? Does anybody remember? No, you don't even remember from 2 days ago, right? That's because we've got bad abstraction, right? Remember what abstraction is. It's information hiding. It's modeling. We don't want to have to worry about the details of, that it's a year or that it's a second or that it's a day, right? We just want to be able to use it. So let's improve this a little bit, right? I'm going to come back over here, and now that I know that the variable name is years and that we've got documentation here that says years, right? Then I know that it's years, right? I want to abstract that away, right? What I want is some unit of time, right? Instead of just years, right? Now remember, when you're designing objects, what's one of the first things that you should do? What's the first question you should ask yourself in engineering? I don't know if I've got it up there or not, but has somebody already done this for me? And yes, in the Java time library, there is a notion of duration, right? And I'll just call it D here. Of course, you have to bring that in because it is part of the Java time library. There it is, right? But what that is an abstract notion of what duration is. This could be days, this could be years, it could be whatever, right? Now, I don't have years anymore. That's okay. I can always convert this duration to a number of years. So let me go ahead and do that now. Years is equal to D dot, and the quick and dirty way of doing this is to get days, is it? Or of days or something. D dot days. There we go, 2 days, right? And then how many days are there in a year? 365. Careful, this is science. 0.25. Why? Because of the leap years, exactly. It's actually not even 0.25, it's 0.24 something, something, something. This is why we have leap seconds as well. But it doesn't happen every 4 years, right? So once I've got that, I should have the same exact behavior, although I have changed the interface now, right? Instead of decaying by 1, what do I need to do? I need to find that duration, or duration dot, what is it, year? Nope, dot, nope. All right, so I'm going to have to create a duration, and I'll call it year, right? Duration year is equal to duration dot of days. Yeah, I'll go ahead and go with days there. 365.25. I don't know if I can do that, or if, yeah, it's just going to be 365 there. And I've already used year here, so what I'll do is I'll call this year duration. There we go. That's just a different variable name. There. Now I don't have to worry about those lower level details, except for when I actually create the duration, right? Anybody could use this, and they could say, well, there are some elements that have half-lives of fractions of seconds. They could do it in terms of fractions of seconds. There are some durations that last for, like billions of years, right? Uranium-235 or 238, whichever one it is, right? And you could have, epochs or something like that. But it is so much better now that I have, abstracted away all those details. I don't have to worry about, well, was it in years? Was it in days? Right? Now that responsibility is mine. I just create the duration that I want, right? And it takes care of it inside the class. It's abstracted away. It's encapsulated inside of the class, right? Was it still working, by the way? Did I run it? I forget if I ran it. Yep, it's still working. Exact same as before, right? All right, so is there any other improvement that we can make here? Well, if years was kind of a bad way of modeling something, maybe also we should take care of that up here with half-life. And also, what about mass there? What units is that in? Do we know? I mean, what I was doing there is grams, right? That's pretty obvious, right? But again, I should probably think about this more abstractly. Maybe I want a notion of a general mass, like it could be in imperial units, it could be pounds, it could be kilograms, or it could be grams, or it could be tons or something like that. I'm not going to go that far today. Instead, I'm just going to leave it to do. Reconsider these two variable types. And unfortunately, there is no built-in mass, right? I would say I need a class to define what mass is, right? And I would have to bring in a library to do that, or I would have to roll my own class at that point, okay? What I want to do is I want to show you one last thing over here, right? Okay? What I've done now is I've modified my isotope class to decay itself. In other words, it is now mutable, it is changeable. We said that that was bad originally when we were thinking about setters here in the demonstration on Wednesday, right? We'll update, what we were doing was we were updating the mass and then we were setting the mass. In other words, we were doing it outside the class, breaking encapsulation. But now we're doing it inside the class, but it's still mutable. That is that it can be changed. How could I get the same nice design without it being mutable, right? Well, I've got a void function here, right? What if I were to say decay yourself and then give me a copy of yourself that represented that decay, right? In other words, I'm not going to change this dot mass. What I'm going to do is I'm going to create a new isotope, and I'm going to return that value instead, right? So let's go ahead and see what that would look like, all right? First of all, I'm going to need the years here. What I'll do is I'll call this new mass, right? So double new mass, right, is equal to that, right? This mass decayed by whatever duration you gave me, okay? Now, obviously, I'm no longer changing this object's mass, right? What I want to do is I want to create a new isotope with that new mass. So isotope result is equal to new isotope, right? And then I'm going to pass in all of those things that we just had, right? The atomic number, the element name, element symbol. So atomic number, element name, element symbol. What else was there? Half-life. The half-life does not change, but the mass does. Instead of giving it the old mass, I will say new mass, right? And then I will return this new isotope result. There we go. All right. Now that let's see. I've got a bug here. New mass. What's wrong with that? Double new mass. Mass. Half-life. All right. Why are you? Oh, wow. Thank you. I did not see that at all. All right, so now I'm returning the mass here. Now, if I were to run this right now, it would actually be wrong because the mass that I'm playing with is never being changed. It is immutable. It's going to go on forever now because it's an infinite loop. What I need to do is I need to change how I use it, right? So what I'll say is sample is equal to sample. Decay yourself. Right? And then I'll take that new sample with the decayed product instead. And if I'm updating that every single time, then great. Right? It works again. Right? It is a little bit better usage of this because I'm keeping my object immutable, but I'm giving you a way to change the object and create a new object so that it is decayed. It has gone from 10 grams now down to 9.75. And then we create another object to go down even further. Right? This does create new objects every single time, and there might be an efficiency issue there, but you've chosen to use Java, so you've already chosen efficiency is not my first priority here, right? All right, so that looks nice, but there was a lot of repetition there, right? I had to pass in the atomic number, the atomic name, element symbol, half-life, right? In fact, what I should have done this entire time is I should have put this keyword in front of all of it, right? That's best practice to do that, but I don't want all that typing, okay? I want to create a brand new isotope that has the first four elements, the atomic number, the element name, element symbol, and half-life. Those don't change, right? But the mass does. So what I can do is I can create what's called a copy constructor. Now you won't be able to generate this because this is a different pattern and it's not recognized by my IDE here. But I can go ahead and create an isotope, right? Constructor that takes another isotope, right? And for now, I'm going to call it that because there's a difference between this isotope and that isotope that I want to highlight. Let me go ahead and leave it like that for initially, right? And all I'm going to do is I'm going to copy that isotope into this isotope. This dot atomic number, oops. In fact, I'm going to go ahead and grab all of this. There we go. And put it all there. And then that dot, right? That dot, that dot, that dot, and that dot. Right? This is what's known as a copy constructor. And generally you don't need, constructors for this course are considered trivial methods. You don't require documentation on it, but I'm going to put documentation on this because when I post the notes, I want you to remember that this is a copy constructor. All right? Copy constructor. It makes a deep copy of the given isotope, right? That. For now, I'll call it that, right? Now that's really nice because over here in the main, anywhere I'm using this, right, I can make a sample of the original, right? So once I've got that sample, I can say isotope original is equal to new isotope, and I'll pass in that sample. And it's created a copy for me, right? Nice, original, spell it right. Doesn't matter, it's a variable name, but you should always spell variable names correctly, right? Now that takes a sample and then it makes a complete copy. That's not what I want to do inside this class, right? Remember when I did this, I'm actually not passing in all of those elements. I am passing in all those elements, the first 4, but then there's a different one over here for the new mass, right? That's okay. Remember that you can have as many constructors as you want to make this as flexible as you want. What I'll do is I'll create another copy constructor here that takes in that, but instead of copying over the mass, it copies over a new mass. So double new mass. All right, there we go. And instead of copying that mass, I will copy in new mass. You see how nice that is? It takes care of all this copying for me, right? And over down here, I don't have to do all that much. I can do far less typing. I'm going to pass in this because it's the isotope that I want to copy, and then the new mass, right? And over here in the demo class, right, it should not have any change. The functionality should stay the same. It's going to produce the exact same table as before. But now, how much more usable is this to me, right? I can create copies. I can create half copies, right? I could come in and change the half-life, even though that's not something that you would do with an isotope, et cetera, et cetera. There's a lot of repetition here, though, right? I see 4 lines that are copied here, 4 lines that are copied here, and 5 lines that are copied over there. So what I'm going to do is I'm going to change this so that I only have to do that once, right? Remember the DRY principle, don't repeat yourself. I'm going to make this copy constructor call the other constructor by passing in that dot atomic number, that dot element name, that dot element symbol, that dot half-life, and that dot mass. Right? Now, how much better is that? I don't have repeated code here. Right? This using the this keyword, that calls a constructor. Here, I'll show it to you. If I highlight that holding down my command key and I click it, it takes me to that other constructor. So this constructor is calling that constructor. Generally, what you want is you want more specific constructors calling the more general constructors. And I'll leave that as an exercise here to do, make this constructor call the more general one, right? Because it'll cut down on my code, right? I'm not repeating the same 4 or 5 lines over and over and over again. It's all done in this one generic constructor. Right? So copy constructors, other constructors, getters, and actual non-trivial functionality here. Now we have this. All right. Any questions so far on encapsulation and abstraction? Otherwise, think of those design principles as you're wrapping up your design document, which is due today. The first draft of it is due today. We're going to want to see something, and I'm going to show you how to do this here momentarily. But we're going to want to see something like this, right? This is called a UML diagram, right? You don't have to generate this until after you've done your code, right? But we want to see a sketch of what classes are you actually going to be putting together. What are its variables? What are its eventually its functionality? Its methods here, right? Ultimately, what we want to see is a diagram that looks something like this. This is called a UML diagram. That's a universal modeling language diagram, right? Because this is a draft, all we're expecting you to do is whiteboard it, draw it up on a whiteboard so that you get the design down. Put it on a piece of paper instead. Take a picture of either one of those and put that into your design document. Eventually, you will be replacing that diagram with a real diagram that looks something like this. Plant UML. The instructions for installing this are in assignment 2 and also lab 5 next week. But otherwise, all you have to do is select whatever you want, right? Isotope. What is the relationship to isotope demo? Come on, there you go, right? Well, they don't really have a direct relationship. But what about a book and a person? Where's my person class? There we go. There it is. Right. So it generates a diagram that shows you what the relationship between these two classes is. Remember, this is called composition. That a book has a book ID, a title, and also an instance of a person, which is in this case, it's the author. Right. That appears in this diagram down here. Also, it's comparable. Right. So it gives me all the information that I would need as a competent developer to look at this and say, okay, I can go ahead and implement that in C# or C++ or Java again, right? Without having to look at any of your code. All right, again, we're only looking for a sketch, right? Of what classes are you actually putting in, right? Do you have a person class? Do you have a company class, right? And we're going to give you feedback on that of, nope, you're missing a lot of classes here, right? You should probably be having more classes there, right? All right, I'll post that later today. Otherwise, we're going to switch gears here. Remember that there are actually 4 pillars to object-oriented programming. We've talked about encapsulation and abstraction together. Now, the next one that we're going to be looking at is inheritance, okay? Inheritance allows you to reuse a class by extending, or extensing is what I'm going to call it, because that's a keyword in Java, extends, right? So inheritance allows you to reuse a class by extending it and creating a subclass, right? So what we have is this child-parent relationship, or this parent-child relationship. What we have is a superclass or a subclass relationship. It follows an is-a relationship, right? And we're going to look at an example here very, very shortly. But otherwise, you can also refer to it as a parent-child relationship, okay? Overall, the design principles that you should follow when you're using inheritance is that general functionality should be located in the superclass so that it can be inherited by all of the subclasses. Right? Specific functionality that overrides the behavior in the superclass belongs in the subclasses. All right? Now, what do I mean by that? Let's look at a classic example here. Animal, cat, and dog. I've got 3 ideas here, 3 entities. Right? What is the relationship between these? So is a cat an animal? Yeah, I would agree. Is a dog an animal? Yeah. Is an animal a cat? Not necessarily. All cats are animals, but not all animals are cats because dogs. Is a cat a dog? Definitely not, right? So what we can do is we can come over here and model that in Java. I'm going to go ahead and get rid of both those now, right? And let's go back to demo, right? And I'll get rid of all of that. Yeah, there we go. All right, there. I'll get rid of that demo, and then what we'll do is we'll create new, I'll go and collapse this too so that we don't have to look at it. Right? I'm going to go ahead and create new classes here. I'm going to create a class for animal. Right? I'm going to create a class for dog and a class for cat. New class cat. There we go. All right. Now, these are just empty classes for now. You can go and come back and add an age, a birthday of your cat or your dog. You can come in and you can add a name, right? Your pet's name. What I want to focus on, however, is the inheritance part, right? So there's nothing to do over here in animal yet, right? Because a dog is an animal, right? So a dog is an animal. Now, the way that you translate that in Java is using that extends keyword that I put up in the notes before. Extends, right? Now a dog is an animal, okay? Let's come up here over to here to cat and do the same thing. Extends animal. Right? Now that doesn't really do anything yet because we haven't written any actual code that gets inherited or overridden or anything like that. So what I want to do first, though, is I want to show you the relationship here using this plant UML. So let me go ahead and highlight animal, cat, and dog. Right? And by the way, if you need to highlight more than one class, all you have to do is hold down on a Mac. It's going to be Command. On Windows, it's probably Control. Right? Usually, this works in any. This is like basic user interface stuff if you've never seen it before. If you want to click on something and then you hold down the Shift key, it'll highlight multiple things there. If you want to click on individual things, but you want to select multiple, animal, cat, and dog. Right? So holding down the command key or the control key or something should do that. There's our UML diagram. There's nothing in those classes yet, so that's why it's not printing. But this follows an is-a relationship. A cat is an animal. A dog is an animal. But does it work the other way? No. An animal is not necessarily a dog. An animal is not necessarily a cat. Right? Does it work the other way? Right? This is called an invariance. We'll talk about that more formally later on. But can a cat be a dog? Absolutely not. Right? Just like an integer can't become a string, or a string becomes an integer, right? Without calling some functions to do it for you. Right? So let me add some behavior here now. Right? I mean, you can add some, like private string name. Let's go ahead and do that, right? And then private int age, right? I'll just keep those there, right? And then, of course, I want to a way to construct something. So how do I do constructors again? Well, you let your IDE do it, right? And you construct it. There we go. Okay. There. So there is my animal so far. What does an animal do? Well, most animals make noise, right? So public void speak, right? And system.out.println, hello, right? So does that make that doesn't make a lot of sense, right? That a generic animal would say hello. Not all animals don't talk, right? Humans are animals, but they talk. So this would be kind of like a person, but we'll come back and fix that later. What I want to do is come over here to dog and fix what I just broke. Right? What's wrong? I do not have a constructor. Right? So when you put this into an inheritance hierarchy, you have to have a constructor that constructs the parent, that constructs the animal there. And I just automatically generated that. It takes a name and its age, and then it calls the super constructor. Do you see variables called name and age in this class? I don't. Where are they? They're up in the animal class. They've been inherited. Remember I said that this is a parent-child relationship? All right, let's go ahead and grab cat, dog, and animal again. Right? You've got the parent up here and the children down here. What do the children do? They inherit things from their parent. Right? There's only one parent in this case, but that's because that's how object-oriented programming works. But we still have to use the same terminology because of family trees. Right? You usually diagram a family tree as you've got ancestors up here and descendants down here. Right? And so the descendants inherit what they get from their parents. Right? And I would have to do the same thing over there in the cat class. Let me go ahead and auto-generate that. Add a constructor. Come on. Click. There we go. And go back. Save it. All right, now it all compiles. The cat and the dog have both inherited the common behavior, the common state of the name, age, and also, by the way, speak. Right? Let me show you what I mean by that. I can create a generic animal. Right? Animal A is equal to new animal, right? John, right? And his age is 35, let's say. Right? Okay. I can also create a dog. D is equal to new dog, and Rover, and 6 years old. Right? And I can also create a cat. Cat. C is equal to new cat, Mittens, and she's 3. Right? Okay. Now, because they've inherited their names, I could, of course, generate a toString method, right? In fact, let me go ahead and print that out and show you what happens here. System.out.println, A, D, and C. D, and C. All right, what's going to get printed here when I implicitly call the toString method? Right? Remember when we first started talking about Java and I did the toString method and it was this gobbledygook, right, that looks like this, right? It is just a fully qualified path name, in other words, the package, then the name of the class, and then followed by this hexadecimal number, which represents a memory address inside of the Java virtual machine. Let me come over here to the animal class and override the toString method to do something different, right? So generate toString, and I'm not going to worry about the formatting here. I'm just going to let the default formatting take over, right? There we go. What happened to Rover there? Rover says that he's an animal, not a dog. Mittens says that she's an animal, not a dog. Why? Do I even have two-string functionality here yet in the subclass called dog? No. What has happened? Again, what's happened is that we've inherited that behavior from the superclass. Let's look at this plant UML diagram once again, right? This speak method, this two-string method, and this, not the constructor, but those two methods and the name and the age, they've been inherited by the cat and the dog, right? You can change that, right? So for example, let me come over here and ask, what does each one of them say, right? So system.out.println, in fact, I don't like typing a lot. I'm going to go ahead and grab that. There we go. And I'm going to insert using code block selection mode here, .speak. There we go. Eek. There we go. I guess, never mind. It doesn't return what do I want to say, a string. So I'll just go ahead and call those. Come on. Go out of block selection mode there then. Sometimes it doesn't always help. There we go. Oh, and I forgot my semicolon everywhere. There we go. All right, what does each one of them say? Well, I've only written one piece of code, right, that says what? Hello. Does the dog say hello? The dog should say bark, right? The cat, does the cat say hello? No, the cat should what? Meow, right? But because I've inherited that behavior, they're all going to say the same thing. Hello, hello, and hello. That's okay, because remember, the general functionality is located in the superclass. Specific functionality is going to be located in the subclasses. What I can do is I can come over here to the dog class, and I can override, there is a keyword there, override, the public void speak method. And override two R's there, sorry. There we go. All right, and instead of saying hello, I'm going to now say .out.println bark, there, because I'm a dog, right? Or this object is a dog. You see how that's changed? Now, the animal says hello, but the dog says bark. Right? What happened to this code? Right? It got overridden, right? Using this keyword here, override. It's actually not absolutely necessary to have override there, right? But it is a good sanity check, because if I don't have it and I misspelled the name, right? There we go. What's happening here is that the compiler is checking me. The method speak of the type dog must override or implement a subtype method. In other words, I misspelled this method, right? Now, I can get away with it if I get rid of that override keyword. Right? It's actually not a keyword, it's called an annotation. Right? And now it's perfectly happy, but that's because it's a completely different method. Let me run it again and it will be back to saying hello, because it's not overriding that speak method, it is creating a brand new speak EE method. Right? Let me go ahead and restore that. The override keyword, the override annotation is not absolutely necessary, but it is something that you should do, override, just as a sanity check there. Let's do the same thing for cat. Right? Cat will now be overridden, right? To say meow. There we go. And we'll come back over here to the demo, and now everybody says what they should be saying. Okay? If there's general generic functionality, then you put it in the superclass. If there's more specific functionality, then you put it in the subclass. This is kind of a toy example, right? Who cares, right? So we'll get to a real example later on, right? I just wanted to demonstrate the ideas there, right? So again, inheritance forms an is-a relationship. A dog is an animal, right? And again, you use the keyword extends. Here's I'll put in the notes here just for instructions for how to install plant UML so that you can get those nice diagrams for free. Because once you've got animal, cat, and dog, right, then you can go over here to this plant UML, and then what you can do is you can take a screenshot if you want, or you can export it as a PNG, and then you can put that into your project, into your write-up, right? So there's instructions on how to get that installed. All right, so some observations before we look at a fuller example. If a class A extends class B, A is a subclass or child class or derived class. B is the superclass or the parent class, or I don't know what the opposite of derived is. The example that we just went through demonstrates that with cat, dog, and animal. Dog is an animal. A cat is an animal, right? But is a cat, is an animal a cat? Oops. Does that follow? Does it work in the other direction? Nope, not necessarily. Sometimes, but not always. Is a dog a cat? Question mark? Or is a cat a dog? Either way. Does that make any sense? No, right? So definitely not. Definitely not, right? This is known as an a covariant, contravariant, and invariant comparisons. Or forget the word, but let me go ahead and pull up a diagram here for you. Let me see, where is my cloud? Come over here, and I want inheritance, and where's my bird diagram? There we go. All right. So different example here. Bring this over. We've got a bird, a robin, and an ostrich, right? Instead of an animal, cat, and dog, right? Now, because I've set it up like this, is a robin a bird? Yes. That's called a covariance. That's always safe, right? A contravariance would be trying to take a supertype and forcing it to become a subtype, an ostrich. Is that always safe? Are all birds ostriches? No. What if you took a robin, made it become a bird, and then forced it to become an ostrich? You would have a type exception of some sort. Just like if you tried to force an integer to become a string or something like that, right? And then you have something that's never safe, a robin and then an ostrich over here. That's called an invariance, okay? Let me demonstrate that over here with the demo class, okay? All right, so there's all the speaking, right? And what you can do is you can do what is called subtype polymorphism. We'll come back to this later on, right? Which means that I'm going to treat a dog like an animal. Animal A is equal, I've already used A up there, right? So A2, right, there we go, is equal to D, right? Remember, what type was D? D for dog, right? In other words, you can treat a subtype as its supertype. You can always treat a subtype as a supertype because this is called covariance, right? Just like in this diagram here. Take a robin, treat them like a bird. Take a dog, treat them like an animal, right? Now, why would you want to do this? We'll talk about it later when we get into polymorphism. But can you treat, and you can do the same thing for a cat, but you can sometimes treat a dog, an animal, like a dog. For example, my animal here, I'll say dog D2 is equal to A2, right? Now, it's not going to compile here because, let's find out what the error message actually says. Type mismatch. I can't explicitly, or implicitly, excuse me, treat an animal like a dog. That is a contravariance. This is a contravariance and requires an explicit typecast. So we've seen explicit typecast before in other languages, C primarily, but what you can do, and in Java as well, right? If I've got two integers here, A is equal to 10, int B is equal to 20, and double C is equal to A divided by B, is that going to work? Is that going to give me, I mean, it's not compiling, but just go with X, Y, and Z instead, right? Is that going to result in 0.05 or 0.5? No, why? What's the problem there? X, Y, and Z, X, and Y, so that it compiles. What's it going to result in? System.out.println Z. What value is it going to be? I'll get rid of this for now. 0, why? Somebody from C must remember. This is called integer truncation, right? That the result of dividing an integer by an integer has to be an integer. So 0.5, but then what happens to that fractional part? It gets chopped off and thrown away, right? This is called, how do we solve that problem? By doing an explicit typecast, forcing one of them to become a double, okay? All right, we can do the same thing here now, right? I can't do a contravariance. Yeah, that's spelled contravariance. There we go. Contravariance, that's how you spell it. But I can force it, right? So here's dog, right? There. Now, is that going to work? Let's go ahead and try it out. d2.speak. What's the dog going to say if it's actually a dog? Bark, right, at the very end there. Can I do the other way? Can I say, take a cat, C2, and force A2 to become a cat? All right, cat, A2. Right? It compiles. What's going to happen on line 28, though? What have I done? I've forced a robin to become an ostrich, or I've forced a cat to become a dog. That's an invariance, right? Invariant coercions. These are called coercions, right? Invariants are never safe, right? So what's going to happen here? Let's find out. Java is going to throw a class cast exception. Dog cannot be cast to a type of cat. Why? Because they don't follow that hierarchy there, right? So this simple picture here underlies a fundamental part of object-oriented programming. When you use inheritance, right, it follows an is a relationship. The supertype is always a subtype, or the subtype is always a supertype, excuse me. A robin is always a bird. A dog is always an animal. But sometimes you can take an animal and force them to become a dog if they were a dog to begin with. But you can never take a cat and force it to become a dog, or a dog to become a cat, because of that invariance, okay? All right, we'll get to why you would want to do this here probably next week when we actually start using this stuff. Actually, yeah, let's go ahead and just start doing an actual example here. What I'll do is I'll take this, and I won't bother with the animal classes. All right, those are pretty simple, and you can watch the video again if you really want those animal classes. You're not going to use them anyway, but at least that will remind you of covariance, invariance, and contravariance. But let's go ahead and actually do a demonstration now. Right? All right. So write code to support a variety of assets. All right. For example, you could have a stock account, right, where you have a stock price and a number of shares. Okay. And then you could also have a savings account, right? A savings account would have a balance and maybe an interest rate, right? Et cetera, et cetera. And then maybe some other kind of class, question mark. We'll come back to that, okay? What I want to do is I want to start out with the stock and the savings account over here, okay? And let's go ahead and close all these. Let me go ahead and start with the stock class. New class. Stock. Right. By the way, should I call it stocks? Do we pluralize classes? No. It's not stocks, it's a stock, right? If you have a bunch of stocks, then you would put that into a list, and your variable name would be stocks. But your class names are never pluralized. So let's go ahead and finish that. Right. Okay. All right, so what should I put into this stock class? Right. Well, I need an account number, for example, a private string account number. Right? And why do I want an account number? Because I need to know, who owns it, right? Well, who owns it? Who owns stocks? Do dogs own stocks? Nope. Private. Who's the owner? What have we used before? Can a cat be an owner? No. Who should be an owner? Or what should be an owner? A string? Yeah, right? Person, good. Good, right? What if I put the owner's name instead, right? String owner name. Is that good modeling? Right? A person has so much more. A person is a first name and a last name, maybe an address, maybe a bunch of emails as you're designing right now, right? So no, it's not just a name, it is an actual person. Remember, that's called composition. That the stock class owns an instance of the person class because that's who owns the stock. What else do we need as I put in the write-up over there? How do you determine the value of your stocks? You take the stock price and then you multiply it by the number of shares. So what else do we have here? Private, double, share price, and private, double or int, number of shares. There we go. So double or int, which one do we want? If you don't own any stocks, that's fine, right? But you should know at least about stock ownership because yes, you can own fractional shares, right? So we'll go ahead and go with double there. Now you go through all the usual stuff of generating a constructor, generating like getters, a toString method, etc. I'll do all that offline because you all already know how to do that by going up to the source up here. Okay. Now let me take care of the other one, a savings account. Right? Class savings account. Actually, I'll just go savings. Right? Oh, is that pluralized? That's that pesky English language, right? No, it's not a savings account. You don't call it saving account. It's a savings account. It's not pluralized. So things can end in an S and not be the plural. Savings account? How would you say that? If I had multiple savings accounts? I don't know. Anyway, what do you need in this class? Like I said in the write-up up there, right? A balance and an interest rate. That makes sense. Private double balance. Private double interest rate. Okay. Do we want anything else? How do we identify this account? We don't? Account number, okay. In other words, I'm going to go over, oh yeah, account number. Oh wait, while we're at it, who owns that savings account? A person. So let me copy pasta and bring that all over here. Now, this is perfectly fine. You can have a savings account and you can have your stock account, right? And those have no relationship whatsoever. Plant UML will diagram this and say these two things are completely separate. But we've got repetition, don't we? Right? And remember the DRY principle. What was the DRY principle again? DRY. There we go. Don't repeat yourself. What are the common things here? If I put these side by side, up side by side, come on, there we go. Everything that I just copy pasted, don't copy pasta, don't repeat yourself. Remember, code reuse is why you want to not repeat yourself. If you have a snippet of code, you put it into a function so that it can be reused. If you have another snippet of code that needs to be repeated, you put it in a loop instead of going copy pasta, copy pasta, copy pasta. Now that we're looking at object-oriented programming, you take state and behavior and you promote it up to a superclass. Let me show you. Let me go ahead and create yet another class over here. New class. What should I call this class? Remember, it has to follow an is a relationship. A savings account is a blank. A stock account is a blank. What would you call them? Asset, okay. Asset. Maybe an account also would have been acceptable, right? And what I'm going to do is I'm going to promote, let's go ahead and move that over here. There we go. I'm going to promote the common behavior. I'm going to get rid of it here, and I'm going to put it up here into the superclass, right? And I'm going to get rid of it in the subclasses, okay? Now, if I look at all of these, I no longer have repetition, but I also do not have any relationship yet. All three of these things are separate. What I need to do now is use that extends keyword. The thing that I made a dog into an animal, a cat into an animal, extends asset, you said. Right? There we go. There's the relationship now. It was just built automatically, right, by me putting in these keywords here. There. Don't leave so much white space though. Right? There, asset. There is the final relationship between all of these things. Our account number and owner, are they now repeated? No, I promoted them up to the superclass and they get inherited by the subclasses. They inherit all these things automatically. A savings account is an asset. A stock account is an asset. Right? So, cool. You don't have to repeat yourself. Right? We are not expecting inheritance in this first phase, by the way. In fact, I would recommend against inheritance until you really have a better idea of how the project is going. You could go ahead and design it initially with inheritance if you want, and we will give you feedback, but we will not be grading on inheritance for phase 1. Assignment 1, which is the design document, is due today, and also if you're going for the bonus, the test cases are due early. Make sure, if you don't have no idea what I'm talking about, make sure that you're following along on CampusWire. Right? But otherwise, we are not going to be expecting inheritance at all until the second phase, assignment 2, at which point we will be grading you on inheritance. Okay? All right, any questions? All right, then I'll see you next week, Monday.